Swayam Prabha. Digital India. Educated India.
Yeah, so I think this session will be conducted by Vrashi. So Vrashi is a expert technologist. I think he's worked on HP Integrity VM. I think I've worked with him many years. He is one of the real geeks in HP. I think we had major challenges with HP VM. It is one of the few. It is probably the only virtualization solution which supports both HP UX and OpenVMS. And I think I mentioned about OpenVMS using more than 2 rings. I think more than 4. I mean, probably 4 rings. I think, and so there's a lot of complexities with that. And I think he's had a lot of fun with HPVM. So I called him in. I think he's worked with Quemu and all also in the recent past. So maybe Avrashi, you can, if you want, you can introduce yourself and then get started. So I have the slides on.
Yeah, Shoma, thanks. I think we can start. You can press.
So let me go to slideshow mode and then you can get started.
Okay, so for today's lab demo, right? So we will create one virtual machine, KVM VM, using a cloud image. So that's the first part of the demo. In the second part, we will actually show how an SRIV device can be enabled and assigned to a virtual machine. So here we'll just quickly go through the steps here. So for installing, creating a virtual machine, you would need a image. All right, so you could do two things. One, this is here what the link what you see. This is to download a cloud image. So it's a pre-built image. So there's no installation required. You can directly use this particular image for your virtual machine. The other way you could do is you could actually get an installation media like an ISO image, and then you could install it. So those are the two ways you could do, but this is a simpler one. So it's quicker to create a VM with this. So that's why we are using this here. So you need not go through installation. So for creating a VM, you need to you can download one cloud image. So this is the path for the Ubuntu 20 is codenamed Focal. So you can download the cloud image. So this cloud image will not have passwords assigned. Basically, you can only do through public private certificates. So if you have to enable passwords, you will have to create one user data image. So in the user data image, you can specify what password you want for your VM. The default username for Ubuntu cloud images are Ubuntu. Okay, so it's a very small file, and using the cloud utilities, right, this cloud local IDs, you can create a disk image out of this. And then using Quemu, you can actually boot this. And when you are when you get the login prompt, you can use this password to log in. And then you can set a new password and change it. So from then on, the image what you have can be used without the user data image. So for modifying this, you will have to directly run it through Quemu. We can't use the libvirt or the other virtualization manageabilities available for KVM. Okay, so this is the first step. So basically you download a cloud image and enable password login. And then the second part is installing the virtualization software. So basically you need to install Quemu, then the libvirt utilities. So this is basically the manageability utilities for managing your virtual machine. So directly using Quemu is not easy. It's very tedious. There's lots of options. So with libvirt manageability, you can you have an easy way to do. There is UI and CLI both for this. So we'll go through the CLI part of it. So this again, you can try this later. So this is the command line for booting the cloud image using Quemu directly. Right. So here, if you notice, so you are giving the name of the machine. So we have just used test, and then you're telling what accelerator you want to use. So you want to use KVM accelerator. and then the CPU. So basically you're saying use the host CPU type, and I want one CPU. So this Mohan, I think we lost the presentation mode.
Oh, is it? Okay. Just one second. I don't know why. 1 second. Now can you see it?
No, it's still not in presentation mode.
Screen as in I can still see the presentation.
Presentation, yeah, it's not in presentation mode.
It's not in a presentation mode. Yeah, slide number 48 it is.
Wonder why.
The presentation was happening. He wants to share.
Not coming up?
No, Mohan.
Why it's getting...
Yeah, maybe I have the slide. Shall I have the...
Yeah, sure. Yeah, if you can do that, yeah.
Let me know when you can see it.
Yeah, I can see it.
Okay. So basically you can specify the CPU, then how much memory. So basically it is 4 GB here. And then these are some of the default options. And then the other two important is the disk, right? So one is the cloud image which you have downloaded. That is one of the disk you need to mention. And the other disk is the user image we just created with the password. And no graphic, you can either use VNC or any other display for having a UI interface. So here we'll use only CLI. So you use the no graphic interface. Okay, so this is here we are just starting the guest using Qemu, directly using Qemu. We are not using any manageability, and then we will modify the password of the image. Once that is done, we will create image using Vert, libvirt. So using the Vert install utility, and then we will start a VM and look at the console. Okay, so I will present my...
Yeah, so I think we should have probably sent this earlier, but that's okay. I'll send the, once we have the file shared with you, I think you can try these out on your own. So instead of we waiting for you to probably try these things out, I think you can try it out at your leisure. I hope you will though, because it's a lot of fun playing with Qemu. And I think we'll now have the second part of the demo. I think, yeah, Rishi, can go ahead.
Yeah. So, okay, so
You can
here
show
you can
LSPCI
see,
and other things within the guest to show how it looks also, I think.
yeah, sure. So you can see my screen. I have the terminal open. Is it visible?
Yeah, I can see.
Okay. So right now we are in a KVM host. So I have downloaded the image. So the first part, right, we download the image, and then we have the user data here. So here basically you're telling what should be the password of your image when you first launch it. Then you're basically saying the password shouldn't expire, and you're basically enabling password SSH password authentication. Okay, so first with that you need to create a user image. So to create a user image, you can use the local ID command. So using that you create an image. So basically you get an image. Okay, so you need now let's take the Qemu command. So it's the same command which is there in the slides. So here, one thing you need to notice is that the order of the disk image, first you need to specify the boot image, and then you need to specify the data image. Otherwise, you will not be able to use this particular password to log in. So since we have used no graphic, you will see the boot logs of the guest in here. So right now I've just started launched the guest. So directly using Qemu. So this should boot the guest. So whatever you're seeing on the screen is the boot logs of the virtual machine. Okay, now that the VM is booted, so the username for cloud image is Ubuntu, and we can use the password which we specified. So now if you see the Qemu image is booted, right? So here you can use the password command, and then you can modify the password. So this is only a one-time thing which you need to do. After this, this will seamlessly work with password. So now we have enabled the password for this particular cloud image. So you can um, shut down this QMO. Okay, so while that's down, so next thing we can do is we can create a VM using the libvirt tools. So here, once you have installation done, you will see a command called virsh. So this is basically a virtualization shell. So you can log into this, and then if you hit help, you will see a huge set of commands which you can use to manage your virtual machine. So so any command you want to do, you can just say give the command name and help, and you will get the details of it. Okay, so here you can use list command. So this will list the virtual machines which are running here. Okay, list the virtual machines which are running. If you want to see virtual machines which are down also, you can use the all, but I don't have any machine which is down here. So this is the virtualization cell. So you could actually go into the shell and then run the commands, or you can, if you don't want to use the shell, you can say virsh and say list. So this will be on your bash shell itself, not on the virtualization shell. You can either use it this way. In that case, every time you type any command, you'll have to append virsh and then only the command. So if you're in the shell, then you can avoid typing virsh again. So that's the only difference. Otherwise, it's pretty same. Okay, so let's look at how to create a virtual machine using virt install. So here, is this font visible? Is this okay? Or should I increase the font?
It's small, but it is visible. You can increase it.
Yeah. Is this okay?
Yeah, it's better.
Okay. So here, if you see virt install is the command to create a virtual machine using the libvirt utilities, right? Then you can use the virtualization type KVM. So some of things you can relate to QEMU. So internally, it is going to translate into QEMU commands. So you can see what install, then the type, then you can specify the name, and you can specify how much RAM you want, right? So this is a 1 GB guest, and then how many CPUs. So virtual CPUs. So we say 2, and then we specify the file name of the disk. So basically you can, if you don't have an extra disk, right, you can directly use the file backed disk image. So this is the image which we had downloaded and we modified the password, right? So this is the image, right? And then you can use the -file option to say this is a file backed disk, and you can use this option. And then we need a network for our guests. So this is the for network, you say I want bridged, and we use a word BR0. So by default, when you when you install all the virtualization packages, right? If you run IPADDR, you will see that there is one virtual bridge or a switch which is created for you. Okay, so this virtual switch can be used for assigning IP addresses or IP addresses for or the network interfaces for the particular guest what you create on this particular system. So if you want to look more about this, so there is a netlist command, right? So netlist will tell you the other networking switches which are available, switches or bridges. And then if you want to look more into it, there is a net dump XML. When you're hitting tab, you generally get to know the available commands. So you can say, and then you can give the interface name default. So here, if you see, so here, if you see, this is the configuration of the virtual BR and virtual bridge network. So if you see the name here, this is says virtual BR0, and that is the interface name which we saw in the IPADDR command, right? So this is the interface which is there, and this is NATed. So basically, it uses a network address translation. So which means that the this particular switch is going to create a private network, and this private network is not accessible from outside this particular host, right? So if you have a different system, then you will not be able to use the IP addresses of the virtual machine to access your guests directly. Okay, but your guest or the virtual machines can connect to outside network. So basically, this switch or will take care of translating all your requests before sending. So the source information from where the packet is sent, right? So that is going to be modified by the NAT logic, and you will be able to communicate outside the network. But from outside, you cannot connect to your guest using this NAT configuration. So there are other modes like bridged connection, but that will need, it will prefer to have another network interface. And in that case, your virtual machines will be in the same network as your host system. In that case, you will be able to communicate from outside. So that is about this NAT. And then if you see, there is also a DHCP server, which is spawned when you actually create a virtual switch. So this DHCP server here, this is the IP range for the DHCP server, and this is the gateway address. So what will happen is when you assign your network device as this particular bridge, you through the VM boot via DHCP, right, will be able to get an IP address when it makes a DHCP request. Okay, so that is about the virtual bridge. And command. Okay, so then we're saying we don't want any graphics. Basically, graphic is none because we'll use the CLI because we don't want to do any installation. So if you want to do, if instead of direct image, if you are using a CD-ROM or an ISO image, then you may need graphics because the installation procedure will require user inputs, right? So you could use that. And here the hyphen import, right? So here basically you're saying that I'm not doing a fresh installation. I'm using an existing image. So and then uh, create a VM with an existing image. So here we can create one. So this terminal. Yes, so we already have a two VM, test VM and test VM1. I'll create one more with test VM2. So another point is that the disk images, right, should be copied into a libvirt directory. So here we have the libvirt directory in var libvirt boot. So all your disk images you need to copy it here in order for the libvirt, or if you are using the libvirt manageability, then if you have a file back disk, then we need to copy it here. Okay, so I have one more additional disk. We'll use this disk and create a guest. So name it VM2. Okay, VM2 and the image name had VM. So now this is inside the libvirt utility. It's called a domain. Now the VM boots. So now you are inside the VM. So if you run ls CPU, so this is used to look at the CPU information. So if you see here, you have two CPUs, right? And then you can see the hypervisor vendor here, which is KVM, right? So if you run the same command on the host, right? This is on the KVM host, you will see that. So this system has 96 CPUs, right? And you will not see the hypervisor field here. Okay, that's one thing which you can notice. And even the address sizes, right? You can see here there are 46-bit physical and 48 bits virtual, which is being used. But for the guest, KVM is exposing only 40-bit physical and 48 bits virtual, right? And also the system model name. So it's being translated as the Skylake Intel Skylake processor. So if you see the model name, there is a small variation. This is what you can see from the host. This is actually a Skylake. So here you see the model name is being modified before it is presented to the VM. So free memory, you can see it's roughly around 1 GB of memory on the system. You can see LSPCI here. So if you see, there are very few devices. Most of them are for legacy reasons. And this is the network device which we added. You can see it says Red Hat, and which is VirtIO device, right? So this is not a real device. This is a virtual Ethernet device which we had added, right? So, and if you see IPR, you can see there is a interface which is available. So yeah, but you don't see IP address. So some images won't configure DHCP automatically. So we can get that done. So to assign DHCP, right, you can go into etc plan. And again, this is, okay, you already have one. You can copy the MAC address here. So address here is not correct. So it should match. I can say net plan fly. And now if you see the interface made a DHCP request and it got the IP address assigned from one of this one. So if you go back and look at XML default. Right, so if you see, this is the DHCP range 162, 122, 254. Right, so here you see 160, 128, 113. So this is the IP address of the system. So let's rename it. So now you can actually SSH onto the VM using the IP address. Sorry. So you're inside the virtual machine, right? So it's the same IP address, right? So you can also connect to outside network. So maybe we can do an installation. So before that, if you are behind a fire, so APT is the tool which is used for. Yeah, so we are inside the guest here. All right, so APT is the tool used for installing command, meaning packages in Ubuntu. So we will do one thing, we'll install a simple utility. Maybe we can install make, right? So uh, if let's say apt install, so here it's actually trying to make a network connection. It's failing here. So if you are under a proxy, right? So at this point, so it's actually trying to connect to archive.ubuntu.com. But since we are behind the proxy, we will have to set up proxy for APT in order to talk to outside this particular network. So even in your case, if you are behind a proxy, then you will have to set up proxy before you can actually communicate with outside world. So so you will have to create a apt conf file. Okay, and you just need to specify the proxy of your system. So that's the only thing you need to do. So now if you try to install, you can see that the installation is going through. So basically it could connect to the web and install your package, whatever you want. So you can basically connect out to the outside from this virtual machine without any restriction with NAT kind of a switch, but you cannot uh, actually means if you are hosting any service or a web server or something from your VM, then you cannot directly use the IP address, because the IP address range which we use here, it is a private range, and it is not known from the outside network to resolve it back to this particular guest. Okay, so in case you can actually spawn off VM pretty quickly like this. So if you want, you can just make a copy of that particular image, and then you can create multiple VMs, and you can set up your own small cluster inside your maybe in your system or in your laptop. Right, so maybe for tomorrow's like Kubernetes, you have the Kubernetes class, right? So in case you want to set up a Kubernetes cluster on your laptop or on your test system, right? You could do it without having multiple systems. So it's very powerful when you want to do development because especially related to network and clustering stuff. Like if you want to do some HPC related testing, you could spawn off multiple VMs, and then you can configure MPI or Kubernetes or whatever you want to. Okay, so this is a quick demo of how you can actually create a virtual machine. Okay, so we will go on. Any questions here? Or we'll go and look at the SRIAV. Okay, so let me share back the slide. Okay, so for the SRIAV demo, so on my system, I have an SRIAV card. Okay, so we'll just go through what setup is required if you have an SRIAV enabled PCI device on your system. So what you need to do to enable what setup you need to do on your system to enable SRIAV. And once you do that, how do you create virtual functions? And then how do you assign the virtual functions to your virtual machine, right? So that is what we'll be looking at now. So the first thing you need to do is you need to enable virtualization features of your platform. So that basically you'll have to do it in your BIOS or the UEFI prompt, whatever you have. Then you will have to modify certain kernel parameters. I'll show you this. So if you are having an Intel processor, then the boot, you'll have to change the kernel boot parameter. So you'll have to say Intel_IM equal to on if it's an Intel processor. If you are using an AMD, then you'll have to say AMD_IM equal to on, and then there's IOMM equal to PT. So these two options you need to add. And then once you modify the grub file, you need to say update grub. So this is going to modify your bootloader or the grub configuration, and then you need to reboot your system. So this is for the kernel, and the other one is for the system. Okay, and then and the rest of this I'll show you in the demo itself. So for the first one, I have a screenshot. I'll just show you the screenshot on how it will look inside your BIOS. Okay, can you see my screen? Is it visible?
Yeah.
Okay, so this is the screenshot of the virtualization settings in the BIOS of a HP ProLine system. So the system I'm using is a ProLine DL380. So here, if you when you boot, right, you'll get option F9, F10, and different option to change your boot order or log into the system utilities. So based on your system, it will be different. So on a ProLine, it is F9. So when you hit on F9, it will take you to system utilities. So in the system utilities page, there is a system configuration option. You hit on system configuration. And then inside the system configuration, you have the BIOS and platform configuration. And once you hit on that, you will see a virtualization options. So inside the virtualization option, you will see three options. One is the virtualization technology. This is for the processor virtualization. So VTI X, whichever what Mohan was explaining, right, for the CPU and the memory related stuff. And then you need to do VTD. So this will enable the IO, MMU, and related stuffs for direct IO, or the pass through, or direct IO is what SRIO, all are same. For that, we need the MMIO support. For that, you will do this. And then you need to do the SRIAV, because there are some additional resources which needs to be allocated for the device, because now the device will be capable of exposing multiple functions, right? So there are hardware resources required. So you need to enable all three. So this won't be same in every platform. So you will have to look at the user manual of your system, or maybe a quick Googling, you will be able to figure out how you can go and modify the virtualization option. So in general, you will either see 2 or 3. So you need to enable this. Okay. So this is for the system. Once you do this, you save the configuration and then you can reboot the system. So once that is done, the next thing you'll have to do is modify the kernel boot parameters. Okay, so here there is a file for the kernel. There is a file called etc default and grub. Again, this file is different for different operating systems. Okay, so for Ubuntu, you could do this, right? So here, if you see hash, if a line starts with hash, that means it is commented out. Otherwise, you can see there are these many options here. So here in the command line Linux default, you can add the, so the Proliant which I'm using is an Intel based. So I have added the Intel underscore IOMMU on option. So if your processor is AMD, then you'll have to use AMD underscore IOMMU on space IOMMU equal to PT. So those are the two command line arguments which is required. Okay, once you do this, you can do a grub update grub command, so which will go and modify your grub configuration sourcing from this particular file. And then so currently I have done this on my system. So to look at the command line arguments of the command kernel, right? So you can do a cat on the proc command line. So if you do this, you will see the command line options. So you can see here we have the Intel IOMMU on, which is there in the command line. And another quick check you can do is you can do a dmessage and grep for IOMMU. So here you should see an IOMMU enabled message in the dmessage. So these two things along with the system configuration will set up your kernel and the system for SRIOV. Okay. On this system, we have one SRIOB enabled device. So lspci command is used to look. Sorry. So this will list all the PCI devices on the system. So there's a lot of devices on this. It's a server grade Proliant system. So here I have one device, one card, which is SRIOV enabled. So this, so let me clear this. So okay, so this is the SRIOV enabled device which is there. So yeah, there's already a virtual function which is created. I'll just remove and I'll show you. So this is the SRIOV enabled card. Okay, so we'll go into one of the device details. So you can, if you want to look at details about device, you can take to sys, then bus, then PCI. So basically the sys file system has an entry for this particular device. So we go to the first one, right? So you go here. So if you press here, you will see some directors which with IOMMU. So this is one way you can identify if your hardware supports it, right? One easy way. You just go into the directory in the sys file system and see if you have IOMMU and then these SIR IOV related entries. So you will see a few entries with SR IOV. Among this one cat, if you want to read the value, you can just do a cat. So here, this device is capable of creating 63 virtual functions. Okay, this total VFs will tell you the device limits. Okay, this is not saying how much is there, and this field num VFs, right? This is going to tell you how many virtual functions are there. So here, if you see, this is actually a virtual function. So I will remove it. So if you want to change the number of virtual functions, right, you can just do a echo onto the particular device, right? So here, so now I have made it 0. Okay, and now if you see here, um, you will not see the virtual function. So the virtual function is now removed. So this is basically to create and delete virtual function. So if you, since we have 63, we can maybe, let's say we do 4, right? So now 4 virtual functions are created. So now if you see, you have 4 virtual functions and they are in a 13.bus device in the PCA path, right? It's in this particular path. Okay. So now let us go into one of the device. Okay. So here, so this is the virtual function. So first let's see which driver has claimed this particular device. So if you see here, you see a driver directory. So inside the drivers directory, and there is a drivers. Okay, so sorry. Okay, so here if you see the standard IXGB driver has claimed this particular device. So in order for the device to be used in your virtual machine, there is one more driver called as the VFIO driver, virtual function IO driver. So you will have to use that particular driver. So basically your device, right, you'll have to assign it to the VFIO driver before you can actually assign it to a virtual machine. Okay, so first you can check which driver is claiming it. If it is the IXGB driver, then you will have to first unbind it from the this driver and then bind it to the VFIO driver. Okay, so for doing that, uh, there is an versh command for that. So so there is a versh dev node command. So if you hit list, it will actually create a configuration for each PCI device. So in our case, we are interested in our device is 1310, right? So 13. So you will see these are the two physical functions, and these are the 4 virtual functions which we have, right? So there is a versh node detach. Then you can provide this. Let's take the 0 only. Hit on it. So it will detach the device from the IXGB driver and assign it back to the VFI driver. So now, yes, right. So you see that before it was the IXGB driver, right? So let's see if yeah. So if you see before it was bound, it was claimed by the IXGB driver. So now it is claimed by the it's claimed by the PCI VFIO PCI driver. Okay, so at this point, now this particular device is ready to be assigned to a virtual machine. So So to add it to a device, you need to create an XML file which looks like this. So basically, you're telling it is the type is PCI, you're telling which driver, basically the VFI or driver, and then you'll have to specify the address of the device. So basically it is 00 bus 13 slot 10 and function 0. All right, so that's where our device is, right? 13 and 10 and 0. Right, it's a simple file. You add this particular file, and then you run this particular command. So here you're saying um, so let's assign it to test VM2. Okay, so we will do it online. So here we are in test VM2. So if I see ls PCI, you will see we have these many devices. We don't see the network device. We have only one network card here. Okay, so using this, we will assign it to, sorry, let me look at test VM2. Okay, so VM2 live. So now it says the device is attached successfully. Now when I do ls, now if you see, right, I see a new device which is being added here, right? So it is in a different bus device function because the resources of the guest and host is completely different, right? This is a virtualized resource, and you can see the virtual function being assigned inside this particular guest. Okay, so this is all about how you can assign a virtual function onto your machine. Mohan, do you want to add anything here?
No, I think this was very good, Rashi. So yeah, I think basically we've seen what we talked about, right? We saw an SRIOV and how you needed TD for it. So we saw the same processes. You had to enable IOMMU on the OS side, and then you had to enable the SRIOV card, detach it from the host, and then attach it to the guest, and then you saw it. So now it's directly assigned virtual function, so you can the guest has full control over it and can talk to it directly. So that's the advantage of SRIOV. You get a lot of, and like Rashi showed there are 63 virtual functions which this particular device supports. There are devices which support even more. So you can really have a large number of virtual machines, which is what some of these cloud vendors like AWS and all do. I think they have a lot of these virtual functions and assigned to VMs on their cloud farms. So I think that pretty much covers the demo. So I've uploaded the slides so you can go through the hands-on lab also. You can try out some of these things. The SRIOV ones, you need special SRIOV cards. So I was not sure if you could get your hands on them. That's why we just showed you a demo of how it looks. So hope this was helpful.